Hi guys, welcome to today's video, grade 11 functions. Without further ado, let's get to it. This chapter has like 4 sub-chapters and finally the summary as you can see on my screen. First, we're gonna look at quadratic functions, that is the parabola functions otherwise known. Let's take a look at the function in the form of f of x is equals to ax squared plus bx plus c. Let's take a look at the effects of parameters on the graph, that is the effects of a, b, and c. X is a variable and not a constant, and hence we don't need to worry about that as of yet. The effects of a on the shape, that is a affects the shape of the graph. If a is greater than 0, then the graph of f of x has a smile shape or concave up, and inversely, if a is less than 0, the graph of f of x has a frown shape or concave down. Now let's take a look at the effects of b on the horizontal shift. That is, b affects the horizontal shift of the parabola, and that is given that a is greater than 0 in this case. First, if b is greater than 0, then f of x is shifted to the left. And again, if b is less than 0, f of x is shifted to right. And again, if a is less than 0, the above two statements flips. That is, if a is less than 0 and b is greater than 0, then f of x is shifted to the right. And if b is less than 0, f of x is shifted to right. Now let's take a look at the effects of c on the vertical shift. That means c affects the vertical shift of the function. For c is greater than 0, f of x is shifted upwards by c units, and inversely, if c is less than 0, f of x is shifted downwards by c units. Now, let's take a look at the function represented in the following form, because there are several ways to represent a parabola or a quadratic function. Let's take a look at the effects of p on the graph. If p is greater than 0, the graph is shifted to the left by p units. And if p is less than 0, the graph is shifted to the right by p units. The effects of q is a vertical shift. It determines whether the turning point is above the x-axis, that is when q is greater than 0, or below the x-axis, that is now where q is less than 0. And the effects of a are still the same as the previous form. It determines the shape, whether it's concave up or concave down. Now, let's take a look at the characteristics of the graph in the following form, as you can see on my screen. The domain is defined as x is an element of real numbers. Now, let's take a look at the range. First, let's take a look at the range when a is greater than 0. I say y to show that I'm going to talk about the range, and then go on to say where y is greater or equals to q, then y is an element of real numbers, because that q is the y value of the turning point. And we know that for a parabola, it can either exist above the turning point or below the turning point, never both. Now let's take a look at the range when a is less than 0. We go on to say y to show that we're talking about the y. Where y is less or equals to q, y is an element of real numbers. The y-intercept, you let x equals to 0 and solve for y. And again, for x-intercept, you let y is equals to 0 and solve for x. Turning point is given by the coordinate or the point negative p is to q. And the axis of symmetry is the line defined by x is equals to negative p. The axis of symmetry is where if we cut the graph vertically, we get two identical halves. Now, let's take a look at the steps you follow when sketching a quadratic function. First, you determine the sign of a, or you evaluate the sign of a. If a is positive, the graph is concave up, and if a is negative, the graph is concave down. Next, you determine your turning point, and next you find the y-intercept, then the x-intercept, if any. There are cases when we don't have x-intercepts or the graph doesn't touch the x-axis. And finally, you find your domain and range. Then you are ready to sketch your graph. Let's take a look at an example. It says, sketch the graph of y is equals to 2 into x plus 1 to the power 2 minus 8. First, I see that my a is greater than 0, so I know that the shape is a concave up or a smile. Next, I go on to say my turning point is defined by negative p is to q, and looking at my function, that is negative 1 is to negative 8. And I see that my axis of symmetry is x is equals to -1. That is the line of axis of symmetry. And the y-intercept, I let x equals to 0. Doing that, I have y is equals to 2 into 0 plus 1, all to the power 2 minus 8. And that will give me a y value of -6. And hence, my y-intercept is the coordinate 0 is to -6. And now I go on to find my x-intercept. I let y is equals to 0. And doing that, I will have 2 is 2x plus 1 all squared minus 8 is equal to 0. And dividing everything by 2, I get x plus 1 is to 2 minus 4 is equal to 0. And now solving for x, I expand to get x squared plus 2x plus 1 minus 4 is equal to 0. And simplifying that a little further, I get x squared plus 2x minus 3 is equal to 0. And now factorizing that expression, I get x plus 3 multiplied by x minus 1 is equal to 0. Hence, x plus 3 is equal to 0, or x minus 1 is equal to 0. And hence, x is equal to -3, or x is equal to +1. And hence, my x-intercepts are as follows. -3 is to 0, and 1 is to 0. And my graph is as follows, as you can see on the far right on my screen. And the next example, now the function is given on a different form. It says sketch the graph of y is equal to x squared minus 2x minus 3. You follow the same each steps. Again, I see that my a is positive, and hence the graph is a smiley shape. The turning point now. This is the formula you use when you are given the function in the form ax squared plus bx plus c. Substituting my a and b and c on my function, I get x is equal to -2 divided by 2 multiplied by 1, and the negatives will cancel each other out to leave me with an x value of 1. And now I'm going to substitute that to x value into my original function to get y is equals to 1 squared minus 3 multiplied by 1 minus 3 to give me a y value of -4, and hence my turning point will be defined by the following coordinate. 1 is to -4. Now I'm going to find my y-intercept by letting x equals to 0, and doing that I will have y is equals to 0 squared minus 2 multiplied by 0 minus 3 to give me a y coordinate of 0 is to -3. Next, I'm going to find my x-intercepts by letting y is equals to 0, and doing that I will have x squared minus 2x minus 3 is equals to 0, and factorizing that expression I get x minus 3 multiplied by x plus 1 is equals to 0, and hence x minus 3 is equals to 0, or x plus 1 is equals to 0, and hence x is equals to 3, or x is equals to -1, and my coordinates will be as follows. 3 is to 0 and -1 is to 0. And my domain, x is an element of real numbers, and my range for y is greater or equals to -4. Y is an element of real numbers, and hence my graph is as follows. Moving on to writing the equation of a shifted parabola. A horizontally shifted parabola. If a parabola is shifted by n units to the right, then x is replaced by x minus n. And next, if a parabola is shifted by n units to the left, x is replaced by x plus n. Now let's take a look at a vertically shifted parabola. If the parabola is shifted by n units upwards, then y is replaced by y minus n. And again, if a parabola is shifted by n units downwards, y is replaced by y plus n. Now let's take a look at the following example. Given f of x is equal to x squared plus 2x plus 3, find f of x if h of x is found by moving f of x 5 units downwards and 2 units to the left. First, I write down the equation of my function. And I know that where I see y, I'm going to replace it with y plus 5, and where I see x, I'm going to replace it with x plus 2. And doing that, I will have the following expression. Y plus 5 is equal to x plus 2 squared plus 2x plus 2 plus 3. And simplifying that, I will get y is equal to x plus 2 multiplied by x plus 2 plus 2x plus 2 plus 3 minus 5. And simplifying that, I will get x squared plus 4x plus 4 plus 2x plus 4 plus 3 minus 5. And grouping the like terms, I will have y is equal to x squared plus 4x plus 2x plus 4 plus 4 plus 3 minus 5. And that will dissolve into y is equal to x squared plus 6x plus 6. And hence, h of x will be x squared plus 6x plus 6. Now, let's move on to finding the equation of a parabola. The best way to do this is to show you through an example. So let's take a look at the following example. It says, find the equation of the following parabola. We are given the x-intercepts and another point, random point. So first, I'm going to write the function in the form y is equals to ax minus x1 multiplied by x minus x2. This is yet another way to represent a parabola. And next, I'm going to substitute in my given points into that parabola so that I can solve for a. And doing that, I will have y is equals to a multiplied by x minus minus 2 into x minus 3. And simplifying that a little bit further, I get y is equals to ax plus 2, x plus 3. And now what I'm going to do is substitute that third point into this equation. And doing that, I will have negative 4 is equals to a multiplied by 2 plus 2 multiplied by 2 minus 3. And that will give me negative 4 is equals to a multiplied by 4 multiplied by negative 1. And that will give me negative 4 is equals to negative 4a. And hence, a will be 1. Next, I'm going to substitute back that 1 into my original equation, which is a multiplied by x plus 2 multiplied by x minus 3. And that will give me y is equal to 1, x plus 2, x minus 3. And expanding that, I will have y is equal to x squared minus x minus 6. And I found the equation of a parabola. Let's take a look at another example. This time around, I'm given a turning point and another random point. Now, this time around, first thing I do is write my equation on that form, y is equal to ax plus p squared plus q. And substituting in my turning point on that, I get y is equal to ax minus 2 squared plus 1. And now substituting in the random point, I get 9 is equal to ax minus 2 squared plus 1. And solving for a, I get 9 is equal to a 2 squared plus 1. And that will give me 9 is equal to 4a plus 1. And hence, 8 is equal to 4a, and hence I get an a value of 2. And now substituting the a back into the equation, I get y is equal to 2 x minus 2 squared plus 1. Now let's move on to hyperbolic functions. Those are the functions in the form y is equal to a over x plus q. The effects of q on the vertical shift of f of x, that is, q affect the vertical shift of the graph. For q is greater than 0, f of x is shifted upwards by q units. And inversely, for q is less than 0, f of x is shifted downwards by q units. Now let's take a look at the effects of a on the shape and quadrants of f of x. That is, a affects two things, that is the quadrants and the shape of the graph. First, for a is greater than 0, f of x lies in the first and the third quadrants. And for a is less than 0, f of x lies in the second and fourth quadrants. Now, let's take a look at the hyperbolic functions in the form y is equal to a over x plus p plus q. A, we've already discussed its characteristics and how it affects the graph, and the same is true for q. Now we have to discuss how p affects the graph. For p is greater than 0, the graph is shifted to the left by q units, and inversely, for p is less than 0, the graph is shifted to the right by p units. The domain is as follows. X is an element of real numbers, but x is not equal to p. And the range is as follows. Again, y is an element of real numbers, but y is not equal to q. Finding the y-intercept, you let x equal to 0 and solve for y. Finding the x-intercepts, you let y is equal to 0 and solve for x. Horizontal asymptote is defined by the following line, y is equal to q, and the vertical asymptote is defined by the following line, y is equal to negative p. The axis of symmetry. We have two axes of symmetry and they intersect at the point negative p is to q. The equation of the two axes of symmetry are as follows. First, y1 is equal to x plus c1, and next, y2 is equal to negative x plus c2. And to find c1 and c2, we substitute in the point negative p is to q into each of the equations and solve for c. Now, let's take a look at the steps you follow when you're sketching a hyperbolic function. First, determine the quadrants. You will be guided by the value of a. Second, find the asymptotes. Third, y-intercept by letting x equals to 0. And next, x-intercept by letting y is equals to 0. Then find your domain and range and you'll be ready to sketch your function. Let's take a look at an example. It says, sketch the function f of x is equal to 3 over x plus 1 plus 2. I see that my a is greater than 0, so the graph lies in the first and third quadrants. And the horizontal asymptote given by the line y is equals to p is y is equals to 2. Or y is equals to q rather, is given by y is equals to 2. And my vertical asymptote is given by the line y is equals to negative p, and hence x is equals to negative 1. Now the y-intercept, I'm going to let x equals to 0, and doing that I will have y is equals to 3 over 0 plus 1 plus 2, and hence y is equals to 5, giving me a y-intercept of 0 is to 5. And next I'm going to find my x-intercept by letting y is equals to 0, and doing that I will have 0 is equals to 3 over x plus 1 plus 2, and solving for x I will have 3 over x plus 1 is equals to negative 2. Cross multiplication, I will have negative 2 multiplied by x plus 1 is equals to 3. And trying to solve for x, I will have x plus 1 is equals to negative 3 over 2. And hence x is equals to negative 3 over 2 minus 1. That will give me an x value of negative 5 over 2. And hence my x-intercept will be given by the following coordinate. Negative 5 over 2 is to 0. Finding my axis of symmetry now. I know that is the point where my axis of symmetry intersects negative p is to q, and hence negative 1 is to 2. And I know that y1 is given by x plus c1, and substituting that equation or that coordinate into this equation, I'll have 2 is equals to negative 1 plus c1, and solving for c, I'll have c1 is equals to 3, and hence y is equals to x plus 3. That is the first equation of my axis of symmetry. Trying to find the next now, I'll have y2 is equals to negative x plus c2, and substituting the coordinate into this equation now, I'll have 2 is equals to 1 plus c2, and hence c2 is equals to 1, and hence my equation will be y is equals to negative x plus 1. I know that a is greater than 0, and I know my horizontal asymptote, I know my vertical asymptote, I know my y-intercept, I know my x-intercept, and I know the equations of my axis of symmetry, and hence I am ready to draw my graph. And my graph will be as follows. It seems a bit complicated, but it really is not if you follow the steps correctly and try to draw a neat sketch. The domain will be given by x. It's an element of real numbers, but x is not equals to negative 1, as you know, and range is defined as y is an element of real numbers, but y is not equals to 2. Moving on to exponential functions. That is the functions in the form f of x is equals to a b to the power x plus q. Let's take a look at the effects of a on the shape. Again, we notice that a affects the shape of the graph. First, for a is greater than 0, f of x is increasing. Second, for a is less than 0, f of x is decreasing. And now let's take a look at the effects of b on the direction, and that means b affects the direction of the graph. And if b is greater than 1, f of x is an increasing function. And again, if b is less than 1 but greater than 0, f of x is a decreasing function. And if b is 0, that means the graph is undefined. Now let's take a look at the effects of q on the vertical shift of f of x, and that means q again affects the vertical shift of the graph. And if q is greater than 0, f of x is shifted upwards by q units, and if q is less than 0, f of x is decreasing or is shifted downwards by q units. Now let's take a look at a function in the form f of x equals to a to the power bx plus p plus q. We've already discussed how a, b, and q affect the graph. We only now need to define how p affects the graph. And if p is greater than 0, the graph is shifted to the left by p units. And again, if p is less than 0, the graph is shifted to the right by q units. Let's take a look at the domain of the function. The domain is defined as x is an element of real numbers. And now the range is defined as, for y is greater than q, y is an element of real numbers. Next, we find the y-intercept and we let x equals to 0. After that, we find the x-intercept by letting y is equals to 0. And next, we find the asymptote of the graph, which is defined by y is equals to q. Let's take a look at how we sketch the function in the following form. First, we determine the shape, then the y-intercept, then the x-intercept, then the asymptote, and finally the domain and range. Now let's take a look at an example. Sketch the function f of x is equals to 2 multiplied by 3 to the power x minus 4 plus 3 over 2. First, I notice that my a is greater than 0 and b is greater than 1, and hence the function is increasing. Y-intercept will let x equals to 0, and doing that we'll have 2 multiplied by 3 to the power 0 minus 4 plus 3 over 2, and that will give me a y value of 1,52, and hence I'm gonna next find my x-intercept by letting y is equals to 0, and that will give me 0 is equals to 2 times 3 to the power x minus 4 plus 3 over 2, and hence I will have 2 multiplied by 3 to the power x minus 4 plus 3 over 2 is equals to negative 3 over 2, and simplifying that a little bit further I get 3 to the power x minus 4 is equals to negative 3 over 4, and I know that I cannot find that exponent because anything to the power of something, it should result in a positive answer. If there's a power, the answer must be positive, and if the answer is negative like it is on my equation here, that means the expression is undefined, or the value of x is undefined, and that means that our graph does not touch the x-axis. And next we can go on into finding the asymptotes of the graph. That is the line defined by y is equals to q, and hence y is equals to 3 over 2. And I know that my domain will be x is an element of real numbers, and range is defined by the line if y is greater than 3 over 2, then y is an element of real numbers. That is, y is greater than the asymptote. And hence my graph will be as follows. And that brings me to the end of this chapter, and hence the end of the video. Please do comment below on the chapters you want me to do next. But for now, thank you for watching. To support the channel and help more students access free lessons, please like the video and subscribe if you're new to the channel. For additional learning materials and updates, visit our website using the link in the description below. Keep studying hard, and I'll see you in the next one. Cheers.